So hello and welcome to the first video of the Vehicle Forensics Guide. My name is Kendrick. I'll be with you for the rest of the videos as well. So this first video is on Sat Nav Analysis. We're going to look at a few different brands and see what data we can get out with them and how it varies between brands. So just before we start, we're going to need FDK installed and open. And we'll need the Sat Nav image files. There should be 3 of them. You might have to unzip them or extract them. Just feel free to pause and come back. So we're going to start with the roadangel.ear1 file. It's a very limited amount of data, but it's a good place for us to start. So now that we've got FTK open, we're just going to add the evidence in. And it is a ear1 image file. So just do this. Just find it wherever you've downloaded it to. So now that we've got the evidence in, we can expand it. And what we're looking for is a save file. You can see we've got some unpartitioned space and a FAT16 partition. So we're interested in the root folder. Here you've got roadangel and RA. We're interested in the RA directory. Here's where we'll find the save file. See, we've got a good selection of files. So here in the save file, there's a lot of files. We can see we've got the date and trip log files. We'll come back to that. We also have this GPS save.dat file. This tells us the most recent saved GPS location entered. So if we were to plot that on a map, we'd get a location. And now we're just going to take a look at some of these trip files. So we can see we've got a start date, start time, end date, end time, start latitude, end latitude, start longitude, end longitude. This one's a bad example because I think they've just started and stopped it. We'll have a look at another one in a second. But for a forensic investigation, this information can be very useful. We can see exactly where they've started, exactly where they've ended, and the exact times. I've done this to the second. So here we go, we can see a more interesting one. And it even tells us the total miles and total hours of the trip. So for a forensic investigator, this could be crucial information. So here we have the favorite.lst file. This tells us a selection of the user's favorited locations. You can see we've got Imperial War Museum. It tells us the address, the latitude, the longitude, the grid location. This all can be useful in a forensic investigation. So to summarise that section, we looked at the roadangel brand of Sat Nav. There is very limited amount of data in this brand, but there is some useful files in the save directory. So we've got the GPS save.dat, which contains the most recent save location from the user. We then have dated trip logs, which are useful. They contain start and end locations and times, which are all useful in an investigation. And then finally we have the favourite list, which contains a list of the user's favoured locations. So now we're going to take a look at the Navman F20 ear1 file. It does contain a lot more data than the roadangel file. However, we do need to look through the hex in order to understand this. So here we've got the Navman F20 ear1 file open in FTK again. We've just got a little notepad for any notes we need. So in the root folder, we keep expanding and we'll find the system directory. This is where we're going to focus on. And the first file we're going to look at is the recent.dat file. So we open that. Now as you can see, it's a lot of hex, it seems overwhelming, but we'll try and break it down. So each record in this file is 520 bytes. And if we look at the length counter at the bottom, we can see we've got a whole record here. Towards the end of this record, starting at offset 508, we can see we've got 8 bytes here. Now these are the latitude and longitude of this record. So if we see the first 4 bytes, starting at 71, finishing at FF, we copy the signed integer using the hex value interpreter. The key is to make sure it's in little endian. So it's basically just reversing the hex values and interpreting it into an integer for us. So we just make a note of this as the longitude, and then the next 4 bytes is going to be the latitude. Save again, copy the signed integer. And now, in order to make this into the correct values, we need to divide by 100,000. So if we do this, so for the longitude, we're going to get, the key is to make sure you keep the minus sign, which I haven't done. So it's 0.47503. And then, same again, divide by 100,000, we'll get 52.13467. Now if we open Google Maps and insert these coordinates, on the notes I've forgot the minus sign, but I've put it in here. Gotta remember the minus. So if we insert these latitude and longitude values, we get our location. So now we're going to move on to the father.4 file. It's also located in the system directory, and it stores up to 200 user favorited locations. In this file, each record is 1,508 bytes in length, with the latitude and longitude being stored at 352, offset 352. So here we can see a record, 1,508. Once again, we're using the length counter at the bottom. So that's our whole record. So now we look for byte 352. Once again, just using the offset counter. You can see we've got it here. And it's the same again, it's 8 bytes, split into 4 and 4. And we just repeat the same process, copy the first 4, making sure we copy the signed integer. So copy that over. And then the next 4. And it's exactly the same process. We divide by 100,000. And this gives us our correct values. Remember the minus this time. Nearly. So then the next one will be 52.03703. If you pull up Google Maps again, this is the easiest way to check you're right, just putting them. If you get in the middle of the sea, you've probably gone wrong somewhere. So you stick them in. Yeah. Fish and mead this time. So now we're going to repeat the process and find the latitude and longitude coordinates of the second record. So I know each record's 1508 in length. So So just find it here again. And we know the latitude and longitude are 352 bytes into this record. So we can start at 15,008 and then count 352 from there. Here we go. And then we know from that point the next 8 bytes are going to be what we want. So once again, copy the first 4 signed integer, second 4 signed integer, and then we divide by 100,000 again, and we've got a second set of values. So now we're going to move on to the root.dat file, once again in the system directory. And this contains the last navigated journey from the user. So it's only one record. And in this file, the coordinates are found at offset 512. So we use length, find them 8 bytes, and repeat the process. Ignore my copy and pasting skills we got there in the end. Just divide by 100,000 and we'll have our coordinates. This is useful in investigation because it proves the last journey that they put into their Sat Nav. So now we're going to take a look at the TomTom Ear1 file. It also contains a range of useful forensic information, slightly different than the other two. TomTom stores contact and caller information, which can be vital in a forensic investigation. So we'll take a look at that now. So we've loaded up the A1 file into FTK, and we'll just expand it once again. And we're focused on the root directory. Within this directory we've got the contacts file, which we'll take a look at in a second. Here we can see the type of files we have access to. A lot more information than the other two. So this contact directory we've got 3 files, but other devices may have more or less. So we can see the first file, call.txt. This is the names and phone numbers of the people that the owner of the Sat Nav has called through the Sat Nav. So this can be very useful in investigation. We also have callers, so people have called the device back. And then we have a contacts file, which is a big range of contacts, which can provide a useful insight in a forensic investigation. So now if we head back into the root folder and have a little scroll down, we should find somewhere the ttgo.bif file. Now this just contains device information about the TomTom, the Sat Nav itself. But this can be very useful. We also see the last phone connection, which could provide a valuable link during an investigation. So the final file we're going to take a look at here is the map.config file. Now this is stored in the root directory within the current map file that's being used. This can be found in currentmap.dat. We know it's the UK and Ireland one, plus major roads of Western Europe. So we enter this directory. See there's a lot of files, but if we scroll down, we can see the map settings.config. We want to make sure we select the regular file, not the file select. Then if we look at our notes here on the right, see the file's got a file header of 15 bytes. We can pretty much just ignore this. This is just telling us what type of file it is. can see the first record begins with 04. It contains the standard header shown there, which is 14 bytes in length. Now we want to look at the XX and the YY. So here we've got 03. That means when the address was entered, they entered a specific house number rather than entering an area or a road. They've entered a number. And if we take a look at the YY, we've got 04. That means it was a home location. And then after this, you can see the next 8 bytes are a longitude and latitude of the nearest road to the location. So it's not 100% accurate, but gives us a good idea. I'm sure you got the gist of this now. It's 4 bytes, not 2. Signed integer, copy. Next 4. We copy it again. And there's no prizes for guess what I'm going to say now. I divide by 100,000. And that gives us our longitude and latitude within the map settings.config file. So to conclude this video, we've seen there's lots of valuable forensic information that can be gathered from Sat Navs. We've seen location data, which you'd expect. We've also seen devices connected, phone numbers, contacts. So it can all be used in an investigation. Thank you for your time. I hope you found it informative, and I hope to see you in the next one. Cheers.